Hi guys, my name is Shubhang Garodia, Chemistry Master Teacher at Vedantu. Today we are going to talk about JEE Advanced Paper 2020 and Paper-1. We are going to discuss MCQ type question, that is question number 10. MCQ type question may be very careful. Try and assess every single option as an independent question. Okay, the first one says FeCl4 minus has a tetrahedral geometry. We'll try and solve whatever we can solve here, otherwise we'll move on to the next slide then. So in the first case, we have Fe3 plus given to us. In Fe3 plus, we know that the electronic configuration is 4s0 3d5. Now, coordination number that is given to us in the question is 4, and we have Cl minus with us, that is a weak field ligand. Now guys, we know that in weak field ligand, pairing does not take place, and so no inner orbital is available for hybridization, and hence the hybridization here will be sp3. Corresponding to sp3, the shape is tetrahedral in nature. So this option is definitely correct. Okay, now let's move ahead to the next one, that is option number B. In option B, he says that M, ethylene diamine is a bidentate ligand, A, ammonia is a monodentate ligand, chlorine is a monodentate ligand. He says that this compound has two geometrical isomers. So let me take it on the next page to draw. So we are talking about here MAAB2C2 having two geometrical isomers. So let's try and draw. So this is your octahedral system. We are placing AA here permanent. We'll not move it from there. Now we have to place B2 and C2. So one option is that B2 goes trans, right? The other option is that AA we keep fixed, but now C2 goes trans. And so there is another option available, none go trans, that is both of them go cis. Yes, absolutely. That is B is cis with B and C is cis with C. Let me go ahead and complete these for you, B, B and CC. So as you can see here, this compound will have three geometrical isomers and not two. So this option B is incorrect. Okay. Now let's talk about the third one. FeCl4 minus has a higher spin-only magnetic moment. We just solved for Fe3 plus, right? No pairing takes place. So let's go ahead and calculate the magnetic moment here, spin-only magnetic moment, which will be mu into 5 into 5 plus 2 Bohr magneton. That's root 35, corresponding to 5 unpaired electron, guys. Okay. Now, the next compound here we were solving here, so let's talk about here itself. Cobalt, ethylene diamine, ammonia taken twice, chlorine taken twice, and here we have a plus sign given. So cobalt 3 plus, that is 4s0 3d6 system, and as you can see, out of the 6 present here, coordination number 6, we have 4 coordinations as SFL and we have 2 coordinations as a WFL. So here it is safe to assume that overall SFL dominates, that is pairing will take place. So in 3d6 system, guys, if pairing can take place, so how do we draw it? 1, 2, 3, 4, 5, 6. We are left with 2 d orbitals. We also have the 4s and 4p empty with us. So based on the VBT logic, we can say that hybridization here is indeed D2sp3. There are no unpaired electrons. So spin-only magnetic moment is 0. Let's go back to our options. So has a higher spin-only magnetic moment? Absolutely correct. And cobalt ion in this has sp3d2 hybridization? Incorrect. It came out to be as D2sp3. Right? So simple question from coordination compounds, not difficult, but you have to be careful for the trap here that you had 4 coordination numbers as SFL and 2 as WFL. So you have to decide what is to be done. Hence answer here, guys, is A and C. We also have the entire typed solution given here for you in case you want to refer it. Okay? And stay tuned for our next question.